Alright, so we're going to look at our definition of a vector and our distance formula. And we've gone over our distance formula before this semester, but I put it on there just to refresh our memory. Okay, so to be a vector is just a directed line segment. So it's a line segment that has an arrow on one end pointing in a direction. And then our distance formula is derived from Pythagorean's theorem, so it's the square root of x2 minus x1 squared plus y2 minus y1 squared. All right, so we got any questions on distance formula or what a vector means? No? Okay. So we're going to graph a couple of vectors. So vectors are represented by bold letters, and it's kind of hard for me to write bold letters on the board, so that's why they're a little darker. But in your book, they'll actually be bolded. So bold U and bold V, those are what we use to represent our vectors. So we're told that U has an initial point of 0, 0 and a terminal point of 3, 2. Your terminal point is your second point, which tells you where you're stopping. So my first point, my initial point is 0, 0. My terminal point is 3, 2, so over 3 up 2. I connect those, and then I draw an arrow pointing from 0, 0 to 3, 2. So that's vector U. For vector V, it has an initial point of 1, 2, so over 1 up 2, and a terminal point of 4, 4, so over 4 up 4. And then you connect those. And the problem asks us to verify whether or not these have the same length. So we're going to use our distance formula. So your distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. So if we let our first point be x1, y1, second point be x2, y2. Then for u, I end up with the square root of x2, which is 3, minus x1, which is 0, squared, plus my y2, which is 2, minus my y1, which is 0, squared. So 3 minus 0 is 3. 3 squared is 9. 2 minus 0 is 2. 2 squared is 4. And 9 plus 4 is 13. So u has a length of the square root of 13. Okay, if I do the same thing for v with my x1, y1, and x2, y2. For x2, I end up with 4, minus my x1, which is 1, squared, plus my y2, which is 4, minus my y1, which is 2 squared. Okay, so 4 minus 1 is 3. 3 squared is 9. 4 minus 2 is 2. 2 squared is 4. So these, in fact, end up being the same distance in between. So when I ask you to verify their lengths, you just use your distance formula. Make sense, or we want to do another one? All right. Second thing we're going to look at today is component form of your vector and your magnitude formula for your vectors. So component form is how we represent our ordered pairs, except since they're vectors, instead of being in parentheses, they're in like little triangle things. Okay, so if we start by looking at our component form, you're given two ordered pairs to form your vector. Okay, and then in order to find your actual vector form, your component form of that vector, you take your terminal point 1, Q1, minus your initial point P1, and that's your first term. And then to find your second term, you take your Q2 minus your P2, and that gives you your second term. And then the magnitude formula is derived from your distance formula, where the magnitude is the length of your vector, and you take the square root of v1 squared plus v2 squared. All right, everybody got that? Okay. All right, so if I look at example 2a, I'm given an initial point of 4, -7, and a terminal point of -1, 5. I need to find my vector form, and I need to find my magnitude. Okay. So this is P1, P2, Q1, Q2. So to find my vector, I take my Q1 minus my P1 and my Q2 minus my P2. So in this case, my Q1 is -1 minus my P1, which is 4. And my Q2 is 5 minus my P2, which is -7. So simplifying those, -1 minus 4 is -5. 5 minus -7 becomes 5 plus 7, which gives me 12. So my component form of my vector is -5, 12. To then find my magnitude of my vector, which is represented by double lines on each side, I take the square root of v1 squared plus v2 squared, where my v1 is -5, so -5 squared, plus my v2 is 12, so 12 squared. Well, -5 squared is 25. 12 squared is 144. 25 plus 144 gives me 169. And the square root of 169, anybody? 13. So my magnitude of my vector is 13. Okay, let's do another one like that. So I'm given an initial point of -2, 3, and a terminal point of -7, 9. Okay, well this will be P1, P2, Q1, Q2. So to find my vector form, I take my Q1, which is -7, minus my P1, which is -2, and then my Q2, which is 9, minus my P2, which is 3. Alright, well, minus negative becomes a plus. -7 plus 2 is 5, -5. 9 minus 3 is 6. So my vector form is -5, 6. To then find my magnitude of my vector, I take the square root of my first term squared, so -5 squared, plus my second term squared, so 6 squared. Well, -5 squared is 25. 6 squared is 36. 25 plus 36 gives me 61, which is not a perfect square, so you just leave it square root of 61. Alright, so component form and magnitude, not so bad. The last thing we're going to look at is vector addition and scalar multiplication. Okay, so how do we add vectors, and how do we scale them or make them bigger by multiplying? Okay, so to add vectors, you have to have your vectors already in component form. So if we have vector u, then that would be u1, u2. If we have vector v, it's v1, v2. And then you just add your corresponding parts. So u1 plus v1 and u2 plus v2. Okay, so adding pretty straightforward. You just add your parts that go together. For scalar multiplication, that's where you're multiplying by some constant. So like if you were multiplying by the number 2, that would be scalar multiplication, where k is some constant, and you just multiply each of your terms inside your vector by that number. So k u1, k u2. Okay, so in example 3a, we're given that we need to find 2v when v is -2, 5. So I'm going to plug my vector in. So this is like 2 times -2, 5. Because my vector is -2, 5. And then it's just like you're distributing the 2. So 2 times -2 is -4. 2 times 5 is 10. So 2v would be -4, 10. Okay, if I want to find w minus v, subtracting is the same thing as adding in terms of your steps. So This is like taking 3, 4, and subtracting from it -2, 5. And we subtract our pieces that go together. So 3 minus -2, our first two terms, and our second two terms, 4 minus 5. Okay, minus negative becomes a plus. 3 plus 2 is 5. 4 minus 5 is -1. So W minus V would give me 5, -1. Good so far. Okay, I'm asked to find V plus 2W. This means I need to take multiple steps.
W is the same thing as U.
Yeah, they just use various letters to represent vectors. Usually letters at the end of the alphabet, not at the beginning. I don't know why.
But if you want to, we could use it.
You could use an A if you felt like it, yeah. Okay, so if I go with V, -2, 5 is my V, plus 2 times my W, which is 3, 4. Okay, so I'm going to distribute the 2. 2 times 3 is 6. 2 times 4 is 8. So 2W is actually 6, 8. I'm still adding -2, 5 to that. So we just group the things that are the same. So our first terms group together, so -2 plus 6 groups together. 5 plus 8 groups together. -2 plus 6 is 4. 5 plus 8 is 13. So V plus 2W is 4 and 13. Alright, and the last thing we're going to look at today is how to find a unit vector. A unit vector is just a vector with a magnitude of 1, meaning it has a length of exactly 1 unit. Okay, so you take whatever fraction you please dismiss the growth basketball players and set. Please dismiss growth basketball players and set. Hi, Jenna. Okay, so to find a unit vector, you just take your vector and you divide it by the magnitude of your vector. Trying to figure out how many problems we have?
Yeah.
Okay, so if we're given a vector -2, 5, and we want to turn that into a unit vector, we have to first start by finding the magnitude of that vector. And to find your magnitude, you take your first term, which is -2, and you square it. And you take your second term, which is 5, and you square it. Square root of -2 squared plus 5 squared. Okay. Well, -2 squared is 4. 5 squared is 25. 4 plus 25 is 29. So I know my magnitude is the square root of 29. So I take my vector -2, 5, and I divide it by the magnitude of my vector, which is the square root of 29. Then you just divide each part. So -2 over the square root of 29, 5 over the square root of 29. Alright, then if we look at example 5, we're looking at writing the linear combination of a vector, which is basically the same thing as finding component form, except they add more letters. Okay, so to find our component form, we label our initial point and our second point, and we subtract them. So let's use U because it doesn't give us a letter. Q1, which is -1, minus P1, which is 2. Q2, which is 3, minus P2, which is -5. Okay, well, -1 minus 2 is -3. 3 minus -5 becomes 3 plus 5, which is 8. So my component form of my vector is -3, 8. So therefore, my linear combination of this vector is -3, I, 8, j. You add I to your first term, j to your second term, and you put a plus sign in between them, and you're done.
What did I?
I means initial point, j means secondary point.
Once you S.
I didn't make up the letters. People way smarter than me and way older than me made up the letters. I just know what they mean. Maybe. Okay, so that's all. When it tells you to do linear combination, all I want you to do is put an I with your first term, j with your second term, and put a plus sign in between them. Deal? I don't know. Okay, Mr. Fry's writing a textbook. Why don't you ask him? Yeah, he's been writing one for a while for problem stats. Okay, so you guys are going to work through page 454, 11 through 18, 25 through 30, 39 through 48, 53 through 66. Mm-hmm.